Hello everyone, welcome to today's video. So in today's video we shall actually look out an interesting combination type problem, so which includes the topics inequalities and trigonometry. Fine. So these are the two topics that I have selected, and I designed this question. So this I have categorized this as a toughest question because the ease of logic, like the time that you actually need to spend to get this logic is so immense, and probably you might not even end up getting the answer. Fine. So I'm focusing upon the very first part, that is inequalities part, and then even in this case, even a perfect logic is needed to solve it. Rather, you will be stuck in between. Fine. So yeah, so most probably this is where the important part lies, and you can just see now. So let k0, k1, k2, so on, kn be n plus 1 points. Fine. So these are n points and this is 1, so n plus 1 points on a plane. If the minimum distance between each 2 points of them is x, so fine, if you're choosing some random points like this, x0, x1, x2 and till xn, fine. So any 2 points, if you choose, the minimum distance between them should be x. So the distance between them should not be less than x at all. Fine. So if I choose this, the distance should be greater than or equal to x. This should be greater than or equal to x. Any 2 points, fine, not 3 points. Like it's not like you're I mean to say you're choosing this line. No, like any 2 points, like if you choose this 2 points, it must be greater than or equal to x. Fine. So this is how it must be. So yeah, then the modulus of k0 k1, modulus of k0 k2, that means the distance. Fine. So if I choose this to be k0, this to be k1, this to be k2 and so on, so the distance, okay, the product of the distance should be greater than x by y whole power n into root over n plus z factorial. Fine. So z is unknown here, y is unknown here, and x is the distance that has been given to us, so we need not find it, so it's just a variable, and this whole power n, and this is root over n plus z factorial. Fine. So n is you can just refer from here, it's from 0 till n, and these are n plus 1 points. Fine. So the total number of points minus 1 is this, and yeah, same is the case in the factorial itself. So if this is the case, then if a is equal to sine power y plus z 17 degrees plus sine power y minus z 34 degrees by 2 whole power y minus z, fine, this is not GAF, this is not GAF, it's just a square bracket, fine, plus sine power y minus z 68 degrees divided by 4 whole power y minus z. So yeah, so you can just infer it from here that you need to find the values of y, you need to find the values of z, so that you can substitute here and you can substitute here to get the actual value of a. Then we need to find the value of sine power y minus z 17 degrees plus sine power y minus z 16 degrees divided by y plus z whole power 2 times y plus z. Okay, so this is not z again. So I differentiated z and 2 in this way. This is z, this is 2. So y plus z whole power 2 into y plus z, and that this total expression is being multiplied by a. So this is the value that we must actually try to find out. So this is the whole question. I hope you gotten enough clarity. So let us proceed now. So we shall start with an assumption that modulus of k0 k1 is less than or equal to k0 k2 is less than or equal to k0 k3, so on, which is less than or equal to k0 kn. So let me change the ink now. Fine. So if I consider this as k0, this as k1, this as k2, this as k3 and so on, and this as kn, so we can see that the modulus, if I assume this to like k1, this is k0, and if I just go on like this is kn, so we can see that modulus of k0 k1 is less than modulus of k0 k2 is less than modulus of k0 k3 is less than modulus of k0 kn. So we will be starting with this assumption. Fine. Whatever may be the case it is, this is the universal truth. Fine. This is the universal truth. That is what is given to us. So you may take any arrangement possible, but the choice of arrangement that we are making should make sure the like we solve it so quickly and in a very doable way. Fine. It's not like we make it so complex. and we finally end up doing nothing. No, we shouldn't do that. So the easiest way is what we must choose. So in this type of problems especially, so k naught k1, this is what is less than or equal to k naught k2, and so on is less than or equal to k naught kn is the assumption that we are taking and proceeding forward. So consider each point ki. Fine. So I shall make those points here: k naught, k1, k2, k3, so on, kn. Fine. Consider each point ki, I is equal to from 0 to 1 to so on till n. Fine. And draw a circle of radius x by 2 units. So what does that mean? So if I draw a radius of x by 2 units, fine. What do you say? So this is x by 2, and yeah, so this is x by 2. So as it is given to us, the minimum distance each point of them is x. So I'll just erase this. Yeah. So this is x by 2. Fine. So this is the case it would be. So we are considering that k naught k1 is the least of all the distances. Fine. And as it is given that the minimum distance of them between any 2 points is x, so we shall consider this itself, this distance itself x. So if that is the case, this is x by 2 circle, and the same is the case with this also. So if you draw it, you will be getting in this way. And now if you draw x by 2 radius circle for this, it may not touch. Fine, it may not touch, depends upon the distance you have taken. So in the same way it just goes on. Fine. So this is how it is. So we can see that either these circles are externally tangent to each other in the very first case, or apart from each other from all the cases from this point. Fine. So I hope you guys are getting it. So this is k naught and this is k1. So as we are assuming that this is the least distance, in this case this is the assumption we are taking, and so then k naught k1 is the least, and we are considering this as x. Now because k naught as a center, x by 2 as a circle, so if I draw this in this fashion, then definitely the other part of this, like from k1 to k2, fine, this is k2, let us assume this k2, this distance would be x or greater than or equal to x. Fine. And therefore the circle of x by 2 radius with k1 as the center will actually touch it. Fine, will actually touch it. And from the other case, from the next case, it may not touch it. Fine. If it is equal to x, then it may touch. If it's not equal to x, then it may not touch. Fine. So this is how it goes on. So in this case, either the circles are externally tangent to each other or apart from each other. Fine. Now consider a point f on any of the ki. Fine. So circle. Fine. Circle ki. Circle ki. What do you mean by circle ki? That is the circle with ki as the center. So if I choose point f here, fine, I'll just change the ink. I'll put it case point f here. Fine, this is the point f that I'm choosing. Then we can write that k naught f, fine, this is the distance k naught f is less than or equal to k naught ki. So this is the ki I'm choosing right now. My I is 2 for assumption that I'm taking, and is plus kif. So kif is this. Fine. So this is the distance. As you can see, this is a triangle, and the third, as we can see in a triangle, the sum of if I consider one side, then the sum of the other two sides will be greater than the length of the third side that we have chosen. So k naught f is less than or equal to k naught ki plus kif. Fine. This is the assumption. Now to maximize this, let us maximize this expression. Okay, let's move to that. Let's do that as up after. Now k naught ki plus what is kf? Kf is actually x by 2, isn't it? So it depends upon us, like whether we are choosing it to be x or greater than or x. And now we have taken that, consider each point ki and draw a circle of radius x by 2 units. So every circle will be of x by 2 units. So this circle is of x by 2 units. So that's the reason this is the radius, because f is on the circle. Fine, f is on the circle of the with the center ki. So definitely this would be x by 2 units. So that's the reason k naught ki plus x by 2. And now this will be less than or equal to, now this is the time for us to maximize this. Fine, the maximum value that can be possible. Now for k2 is what we have did this, right? For k2 is what we have did this. What if the f is on kn? Fine, what if the f is on kn? So in that case, the distance would be k naught kn, and that will be the maximum. From here you can see here from the condition that we have taken k naught kn plus half k naught kn. The reason behind writing k naught kn is, here the value is x. So I shall take some more dark pen here. So the value is x. So here we are actually trying to maximize each and every value. So the x is nothing but the minimum distance that needs to be there. Like if the minimum distance between each 2 points of them is x. So that means x is the distance that is the minimum that is between 2 points. And what can be the maximum distance as per the condition that we have taken? Mod of k naught kn, isn't it? So k naught kn would be the maximum distance. So that's the reason instead of x we are replacing it with k naught kn. And also as stated, the reason behind k naught ki and k naught kn is also clear, I guess. So it's like taking the last circle, fine, taking the point of the center of the last circle, fine. Maybe here we can assume the kn, fine, and taking that circle. This is the center of the nth circle. So and you can consider the radius, any sort of radius. And now this is less than or equal to has so we can just add them up. We get 3 by 2 k naught kn, isn't it? So k naught f is less than or equal to 3 by 2 k naught kn. What can we infer from this? Right, so f is any point on the ki, so I can even be n, isn't it? So if I take any point on any circle, like f point, let us consider f point at any of the circle, and k naught is the center, like means the center of the very first circle, this one. So the distance between that point f and the k will be less than or equal to 3 by 2 k naught kn. That means all the points are covered with the circle with center k naught and radius 3 by 2 mod k naught kn. Fine. So I hope you people got this point. So with a circle of radius 3 by 2, let us consider this as 3 by 2 k naught kn, and this is k naught, and this radius of like could cover all the points in between them. Like there are n minus 1 circles. So as per this condition need to be noted, because this is the assumption that we have taken and moved forward. So this need to be taken care, and following that condition, whatever may be the n minus circles are, they will be in this position itself, like they will be inside the circle itself. I hope you got it. So this is the reason we can assume that we can move forward with this statement, like pi into 3 by 2 k mod k naught kn whole square is greater than n plus 1 pi k plus k by 2 x by 2 whole square. I hope you got it. So the radius like as said, this is assume the bigger circle. So this circle covers all the circles inside it. So that is the reason we have considered, and this radius has 3 by 2 k naught kn. So 3 by 2 pi of 3 by 2 k naught kn whole square, that is pi r square. Pi r square is the formula that we are using it, is greater than n plus 1 pi x by 2 whole square. X is the reason we saw already, like this is the x smaller circle, so the distance this is x by 2, so that is x by 2 whole square and n plus 1 into n plus 1. So I hope everything is clear till this point. So this makes the equation to be 3 by 2 k naught kn greater than root over n plus 1 into x by 2, and from this we can say that k naught kn is greater than root over n plus 1 into x by 3. Fine. So now substituting n is equal to 1, n is equal to 2, so on, we get that k naught k1 is greater than root 2 x by 3, k naught k2 is greater than root 3 x by 3, and so on till n plus 1 points. So we just need to multiply them. So that is when you multiply them, we get root over n plus 1 into n, so on till 2 into, because there are totally n times we are multiplying it, so we get x by 3 whole power n. So that is, so this is basically nothing but n plus 1 whole factorial. So that's root over n plus 1 factorial into x by 3 whole power n. So on comparing, we note that y is equal to 3 and z is equal to 1. So that are like these are the conclusions that we can derive from the very first question. And now, so on substituting the values, the equated A is sine power 417 plus sine square 34 by 2 whole square plus sine square 68 by 4 whole square plus so on till 8 terms. As we know, sine power 4 theta, like sine power 4 theta is equal to sine square theta into 1 minus cos square theta, and that's basically sine square theta minus sine square theta cos square theta, and that is sine square theta minus sine square 2 theta by 4. So we are actually trying to make into a telescopic series. Fine, that is the main motto, because we need to cancel the terms. Not it doesn't like we cannot solve it just like that. So on substituting the values of theta, we get sine square 17, like theta to be 17 is the first case. So sine power 4 17 is equal to sine square 17 minus sine square 34 by 4, like 2 into theta, 2 into 17, 34. And now keep theta to be 34, we get sine power 34 is equal to sine square 34 minus sine square 68 by 4, right? So now so we can substitute the terms that we have got. So sine power 417, that is sine squared 17 minus sine squared 34 by 4. We can just substitute here. And sine power 434 is equal to sine squared 34 minus sine squared 68 by 4 in this place, like here. And when we do that, we get sine squared 34 by 4 minus sine squared 68 by 16. And then plus, we can just move forward. So we have found a telescopic series here. So we can just cancel the terms. And then after that, we can actually end up with a is equal to sine square 17 minus sine square 216 by 4 power 8. So that is sine square 17 minus sine square 16 divided by 4 power 8. So this is the end. So I hope you guys actually enjoyed this. So you can actually multiply with the term that are given to us to multiply. So here there's a small error, so you can just ignore this. Let me do that with rate. Yeah, so you can just strike this off. So the question is all about the denominator y plus z whole square whole power 2 into yz, 2 into y plus z is only for the second term, that is sine power y minus z 16 degrees, only for that. Fine, and you can just multiply with the a that we have got. I hope you guys enjoyed it. So the very most important thing that we can actually learn from this is actually looking out at the problem. So here it's a clear cut question that's been asked to us. We need to find the minimum value. Fine, which is the minimum value, like I mean the minimum point that is not included in the set. So this point, this one, the value of this, which is the least that it could be, but it's not included. So for that reason, we actually need to make sure we cover all the points, right? K0, K1, K0, K2, K0, Kn. So it's like covering from K0 till the end point. All this must lie, like all that minimum distance must be this. So for that reason, this K0, the K1 can be here, K1 can be here, K1 can be here, K1 can be here, K1 can be here from K0. We don't know what is it. So we must take some condition and we must actually move forward. And the most efficient way is by dealing with a circle, taking a circle and make sure like all the points that we have considered, like from K0 to Kn, are inside it. And that makes the our work so easy. So that's how we need to think while solving such problems. And then coming to the second one, it's all about framing telescopic series so that the terms gets cancelled, and finally we'll be left with a very simplified answer. I hope you guys enjoyed this problem. So this is all about it. Like it's been a while since I've uploaded any video. I'm taking a lot of time for all the arrangements that need to be done. Thank you for watching it. Stay tuned.